Here we go, math students. Today we're going to be doing chapter 8.5 of the absolute value. We're looking at the absolute value equations today. So we're going to write, solve, and do some graphing of equations. Here are the three examples for your notes. Example E, example Q, and example U. E, Q, U for our equation notes today. These are the only examples that we will have for our foldable for this section, so you can space those accordingly. Again, pause the video, copy these down, and then I'll go through the explanations as you take the notes. Example E, the temperature of an enclosure for a pet snake should be about 80 degrees Fahrenheit, give or take 5 degrees. The give or take 5 degrees means that you're going to add 5 degrees and take 5 degrees away. We talked a little bit about this give and take when we talked about elections and we talked about a margin of error. We show this margin of error or this give and take using the plus and minus sign. In this case it's a plus and minus 5 because it's give or take 5 degrees. So it can be 5 degrees higher than 80 or 5 degrees lower than 80. So 80 is our optimal temperature, but the temperature can vary 5 degrees either direction. This is an example of absolute value. So this is taking a real life example, temperatures or margin of error of an election, and putting it into mathematical terms and mathematical equations. The mathematical equation is the absolute value of x minus 80 equals 5. Remember from before we talked about how the middle number, this 80 is like our middle number, and the distance for each of the solutions is given by that absolute value. So in this case it's given by that 5. Okay? So we're going to solve this using the two cases that we talked about in our earlier set of examples. The two cases for this one are the positive case where x minus 80 equals 5 and the negative case x minus 80 equals negative 5. So we have case 1 and case 2. We're going to solve these just the same. So we're looking at when this inside equation, this x minus 80 can be either positive 5 or negative 5. So we're going to solve it just like we would solve a regular one-step equation. Add 80 to both sides. For this first one, we bring the x down. We get x equals 85. In this case, it's 85 degrees. In our second case, our equation separator, again, same steps. Add 80 to both sides. And we get x equals 75 degrees. So 85 degrees is our maximum temperature and 75 degrees is our minimum temperature. We'll write these answers in our set notation. Okay, so our set notation with our brackets, 75 and 85 are our two solutions. If we graph these on a number line, 80 will be our middle number, just like we said up here in our general equation, x minus 80 is the middle, and our distance that we're going both directions is 5. So this is where we're going to put our numbers, our 75 and our 85, our solutions, on the number line. And we go ahead and put those dots on the 75 and the 85, our minimum temperature and the maximum temperature. So there's our solution. We have it as a solution set, and we graphed it. Next, we're going to look at example Q and example U. So we'll just scroll a little bit here. In example Q, I wrote it just a little bit differently. I wrote it with the 15 on the left and the absolute value over on the right. Notice this is an absolute value symbol. It's not a mixed number. It's not 1 and 3/4. It's absolute value of 3/4 n minus 3. Again, we're going to do our two cases. Our case 1, where we have 15 equals 3/4 n minus 3. So we're looking at that inside the absolute value. We're looking at case 1 when that's a positive 15 and case 2 when that's a negative 15. Okay, and now we're going to solve these just like we solve a regular two-step equation. Draw our equation separator, adding 3 to both sides gives us 18 equals 3/4 n. Now we have a fraction times the variable. When we have a fraction times the variable, we need to multiply by the reciprocal. Okay, and we're going to make this 18 over 1. There's a little bit of simplifying that can be done. The 3 and the 18 simplify to a 1 and a 6. A bit hard to read up there. That's a 6. Okay, so we have 4 times 6, which is 24. And over here, 3/4 times 4/3 is 12/12, or 1. That's the multiplicative inverse. It equals 1. So we just have regular n. So there's one of our solutions, 24 equals n. In the next example, we still have the same equation. So I'm going to draw my equation separator. We're going to do the same steps as we did before. So I did a +3, so I'm going to do a +3 on this one as well to get rid of that constant. We'll deal with the coefficient part next. So we get negative 12 equals 3/4 times n. And next we're going to multiply by that reciprocal again. So times multiply 4/3 times negative 12. Again, I'm going to put that negative 12 over 1. Do a little bit of simplifying. The 3 and the negative 12 give us a 1 and a negative 4. So we have 4 times negative 4, which is negative 16. And again, over here on the right, we get just an n. So our solution set is negative 16 and 24. Okay? Example U is kind of a trick problem. It's a trick problem because the absolute value, here's our two absolute value symbols, okay, the absolute value can never equal a negative, okay, because by definition absolute value is a distance away from 0. That distance can never be negative. All of the other problems we've ever done have a positive absolute value. So there will not be any time that this inside here, if you take the absolute value of it, it will never equal a negative. Okay? You might have negative numbers inside of the absolute value. You can have 0 inside here. You can have positives, whatever, decimals, fractions, whatever you want inside of the absolute values. But once you take the absolute value of it, it must be a positive. Okay? So because of this, this problem has no solution. So we would just write no solution. Okay? There's a couple more ways of writing no solution. One of them is a circle with a line through it. Another one is called a null set. And another way of writing it is with two brackets with nothing in between it. So using that set notation, but it's empty in there. There's nothing in it. So we call that empty set. So these are the different ways of writing no solution, or saying that there's no number you could put in here for x that would make this a true sentence, because absolute value can never be a negative. Okay, I've got one more vocabulary word, and here it is, the no solution vocab. Again, pause the video if you need to, copy down this vocab, no solution. No value for the variable exists that would make the equation or the inequality true. So this works for equations and inequalities. Hope you learned a lot today. Have a good one.